Recording. Okay. Good afternoon, everyone. Once again, no? So I'd like to review and answer the assignment, and I'll give you an example, another program as an example for the use of a CF, no, count forward, because there was a request to give an example for counting forward. We earlier had counting backwards, no, and we are going to use them again. Okay. Do you have questions so far? Okay. 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 The first, I'm sorry, no. Let me raise the. I have this. I have here the worksheet for the solution of all the problems. I'm going to upload this anyway, no, to our regular site. I was not able to upload it earlier because I have no connection with Daigler. Okay. So anyway, I'm able to connect now, so I will be able to uh, upload this, no, later this day. So can you see my worksheet, everyone?
Yes,
I
sir.
hope so.
Yes, sir.
Yes, sir. Yes, sir.
So the first program is to compute the sum of the first four numbers. No, do you follow? I'm sure you know how to do this directly. There's a short way to do this. You can just N004, N003, N002, N001, and then you multiply them, you add them directly, no, and then you will have the result. But what I'm trying to do is to uh, revise the factorial program, the fourth factorial program, and compute the sum, because the main difference between factorial and summation is instead of using multiplication, we will be using addition. Right? In the fourth factorial, we do 4 times 3 times 2 times 1. In the sum of the first four numbers, we do 4 plus 3 plus 2 plus 1. Okay, and then we are trying to structure it in such a way that we could convert it into a loop version. Okay, a loop version. The good thing about a loop version is we can use it to compute for the sum of any number. Okay, ranging from 1 to 1000, no, and we will have the same code, and we don't have to rewrite the code all over again, okay, each time, right? Okay, so anyway, like the factorial program, ST000 will use a next addend. In the factorial program, we have the next multiplier, but here we have the next addend. The next addend is 4 because the first partial sum is 4. Okay. Any questions so far? Then we have a standard decrement every time this is constant at 1, and our partial sum, which will be the result, will be stored at ST002. For the moment, that's all. No. Let me freeze the panes. Naka-freeze man siya. Freeze it again. Okay. So we say N004 because this is our first addend. N001 our decrement, and N0021 as our partial sum. Okay. The first thing to do is to multiply, because we are going to compute the partial sum borrowed from the factorial program. So 002 this time is 1, and 002 is 4. So 1 times 4 equals 4. The egress axis will have 4. Do you follow? And we'll store the first partial sum to be 4. Okay? It's a times, not a plus, because 4 plus 1 will be 5. Okay? The next step is to compute for the next addend. Okay? Remember, our current addend is 4. We want to have it as 3. The next addend is 3. So we'll do a minus. We'll load the 4, L00, and we'll load our decrement, which is 001. So 4 minus 1 will become 3. And then we'll store it here. So our next addend is 3. Do you follow? No, next addend is 3. Okay, and then we'll do an add because it's still a 3. L002, what is L002? Our partial sum is 4. L00, our next addend is 3. 4 plus 3 is 7. And we will store it at 002. Any questions? Any questions? So 7, no? We started at 4, 4 plus 3, 7. And then we compute for the next addend from the previous addend. So we'll have a minus from L00, which is 3. And the standard decrement is 1. So 3 minus 2 is 3 minus 1 is 2. And we'll store it here. That's our next addend, which means we will add the partial sum to the next addend. Okay. So now we'll proceed with the add. L002 is 7. The partial sum is 3. Or rather, the addend is 3. So 7 plus 3 is 10. We'll store it again to our partial sum, so which is 10. Do you follow? So 4, tama ba tayo? 4 plus 3, 7. No, this is not 3. The next addend, by the way, mali, no? The next addend is 2 here. Because this is all 10. 7 plus 2. No? This is a 9. So this is a 9. Okay, I made a mistake. The next addend is 2, not a 3. We're already done with 3. We'll compute the next addend from 0, 0. We subtract 1. So this is a 1. And the next addend is a 1. Okay? Okay. Okay. Recap run out. It's okay, no? This is recorded already anyway, no? So we'll compute the last partial product, which a rather partial sum, which is 9. The next addend, which is 1. So 9 plus 1 is 10. Okay? So we'll store it as the final result, which is 10. And we do a PBH. P means print, to print the result to the last card, and B, bells, rings a bell, and then hold. So we have the final answer, which is 10. If that's correct. 4 plus 3 is 7, plus 2 is 9, and plus 1 is 10. Do you follow? Any questions so far?
Sir, kung may isa ra ka mali, sir, mali ra na ano, kung mali magud na akong partial sum na ako sa first, instead of 1, 0 ako nabutang, sir. Pero
just get you
almost the same, sir.
Anyway, this is not a graded assignment, okay? This is not a graded assignment. I'm only requiring, this is only a requirement for your first formative test. Okay? You still have to pass because you need to take the first formative test, which will be before the month ends. No? Siguro a week or 2 from now, you will have your first formative test. And then you are required to pass this. You will have a short deduction, no? But anyway, as long as you pass, you have the correct logic, you will be allowed to take the first formative test. Am I clear?
Sir, check pa rin yan, sir. Like, giving a comments.
Okay? Because as I have explained in the beginning, no, that all formative tests are required, which means you have to first pass the formative tests. So this is a requirement to your formative test. Formative test 1 is a requirement to formative test 2, and so on and so forth. Do you follow? I have explained this in the past. You have to pass all assignments, because assignments are considered as performance assessment, formative performance assessment tests. Do you follow? You need to pass this. Okay? So those who are not able to pass, you can still pass by email. Next time around, I will not accept assignments by email. Okay? It's very difficult to grade assignments by email. Any questions? So a slight deduction, no? 10 points each, maybe you get a 9, no? Okay, I'll look at the code myself. It's very difficult to make a judgment if I don't get the whole code, no? Anyway, if the logic is correct, no? More or less, you'll get a passing grade, okay? Okay. So anyway, we have the correct answer, which is 10. Now, let us proceed to the next item, which is to compute the average of the first 3 numbers. No? Okay? What's the difference between computing average and computing sum? They're the same, almost. But there will be a final step when you are computing the average. You will have to divide the sum by the total number of addends. Okay? Paraiso has a question. Paano pag na-draft? Draft is okay, no? The draft is okay. I can still check the draft. Okay, there's no need to re-email if you pass a draft. I will give a grade to a draft. Okay? Okay. So anyway, let's proceed to the average, no? So ganito yun. The problem with computing the average is if we are going to divide by the next addend because we store it here, the next addend will be gone by the time we are finished with the computation of the sum. Do you follow? It will be gone because we are going to constantly decrease it by 1. So at the end, we will not have the final addend as a divisor in order to compute the average. So we are going to use a third storage, which is ST003, to store the average divisor. Do you follow? Do you see the no? Do you see the worksheet? Let me erase first. Okay. So our next addend is N000. Do you follow? Is in and the decrement is still in 001. The partial sum is in 002, but the divisor is in 003. They will have the same value as to the next addend initially. Do you follow? But the
My
next
question was, sir,
yes.
okay lang ba, sir, if like gi-input mo yung 3, 2, 1? Like hindi mo siya gi-next added decrement per gi-isa mo sila add?
Yeah, it's okay. Okay lang. But I'm doing this because we are going to use the average with a loop. Okay?
Okay. Para ma-illustrate lang siya.
Right? Pwede mo isa-assign 3 plus 2 plus 1 and add them directly. Okay? But this is in preparation for the... Anyway, it's okay, no? There's no problem. But you can... I'm doing this because the next version, which is a loop version, will be a slight revision. No? A slight revision of this program. Okay? Do you understand my point?
Yes, sir.
Okay, so you have to trace this, no? So like the first we are going to 002, which is 1, 003 is 3. So 3 and we put it here. No, so 002 pala. So dito yung first partial sum, which is 3. We compute the next addend. 00 is 3 and the minus, no? We do a minus. 3 minus 1 is 2 and we store it here. Okay? So we'll do another plus, no? We are going to add the next addend to the partial sum. Okay, so we do a plus. The partial sum is 3, which is NL002. 2, yes, you can copy it here, no? Ito, 3. And then L000, which is 2. Ito yan, no? 2. 3 minus 2 is 1. Or rather, sorry, 3 plus 2 is 5. Okay? 3 plus 2 is 5, and we store it here at our, no? Okay? Okay. So the next partial sum is 5. Okay? And then we do a minus to compute the next addend. 000 is a 2 this time. Then 1 is a, okay. So 2 minus 1 is 1. And we store it at 00. So our next addend is a 1. So we'll do a plus. We'll say 5 because 002 is a 5. We have it here, no? We have copied it here. And 00 is a 1. So 5 plus 1 is 6. And we'll store it here. 6. Okay. We're done with a 6. I'm sorry, 6. So we're done with our summation. The next thing to do is divide. So it's a good thing that we have stored it to ST003 so that we can divide what is in ST002, which is 6, by the 3 which we kept in memory. So 6 divided by 3 is 2. Okay, S002 will paste it here. 6 divided by 3 is 2, and we have a PVH. So the average of the first 3 numbers is 2. Do you follow?
Sir, nakoy duha ka question, sir.
Yes, please. What's the first one?
First of, sir, nga naman multiplication ng first command, sir?
Because we cannot do an addition. Okay? We cannot do an addition because 3 plus 1 will make a wrong answer. Actually, you can do away with this. Okay? There's a version to do away with this. Can you do a minus right away? Minus 3. Can you proceed to this?
Ang sa ako magod, sir, kay na ako, sir, 0 ang partial sum, tagbot nga na 0 para 3 3 plus 0. So 3 gihapon ng
Of
ingress
course, there's
axis.
another way to do that. You can do a plus, no? Pwede rin naman plus dito eh. Di ba? Actually, this is only a technique to set up the first partial sum, which is 3. Di ba?
Okay.
Because this time, we only have 3, 1, and 1. If you are going to do 3 minus 1, it is 2, which is wrong. We have to compute the first partial sum. Now, if you have a 0 somewhere, you can say plus 3 minus 0. Do you follow?
So, okay ra gihapon na to, sir, na
Yes. Because the first step is to compute the first partial sum. In the first 3 numbers, ang numbers lang na available natin is 3, 1, 1. If you have 3, 1, 1, 0, no problem because you have a 0. You can do a minus. Diba?
Okay, sir.
Mahirap pag set up. You cannot set up the first partial sum right away if you start at 3. On the other hand, if you started at 1, it will be much easier. No? Do you follow?
Okay.
You can start at 1, the other way around. Instead of a decrement, you will have an increment of 1. What's the second question?
Nga naman 3 ang average divisor, sir?
2. Average divisor?
Oh,
The divisor because there are 3 numbers.
kanang so dili siya specifically para ra kana sa na problem, sir, dili siya pwede magamit sa lain na numbers sa
Yes.
average number.
If you are going only for 3, do you follow? Kasi this is without loop. This can only be used to compute the average of the first 3 numbers, not the average of any set of numbers.
Ito ka, sir. Thank you, sir.
Okay. So can we proceed now? So anyway, we'll convert this into a loop. Let's look at. I have a correction to the to the computation of CF and C. Yeah. Let's open this. No. How the CF behaves. Okay. How the CF behaves. The CF you can compute how the CF and the CB behaves by looking at the egress and the ingress axis 1. Okay, the run-up lever will be set if the egress and the ingress axis 1 will have the same sign. Okay, actually it's as if the egress or the last result will become 0. Okay, do you follow? Ganon din yun because you will have to look for a 1 minus 1. So it's like this, no? So in case of 4, 1 minus 4 will set the lever. 1 minus 3 will set the lever. But 1 minus 1 will not set. Do you follow? So ito ang babantayan natin. 1 minus 1. When we reach out 1 minus 1, we will not jump. We will only jump if there is a negative or the sign of the egress is different from the sign of the ingress axis 1. Let's have an example. Okay? Do you follow? So ito yun. Anyway. So, no? This is the average with the loop. Let me erase the trace. Can you all see that? Pareho lang naman, di ba? We have the next addend, which is 3, the decrement, which is 1, the partial sum, which is 1, and then the average divisor, which is 3. If you are going to compute for 5, you have to change both the... Okay, baguhin na lang natin ito, no? Para hindi what can we do that? Okay, let me change this, no? Baguhin na lang natin ito para there will be no ano. So we are going to L 00. We'll do a times, no? Wag na lang, no? Because what I'd like to do is the 003, so we'll get rid of this. Okay. The first partial sum we'll also do an S003. Okay, so this becomes 3. So therefore we will not have an N003 here. Okay, do you follow? This example computes the average of the 3 numbers, but if you're going to make this 4, you only have to change the first line. For example, you can say N0004, or you can say N0010, or N00100. This will now compute the average of the first 100 numbers. Do you follow? Do you follow? Okay, let's erase this. Let me erase this first. So get rid of the previous trace. No? Okay. Can you see all the numbers, the whole worksheet? Okay. So likewise, no, our next addend is in, we are going to compute, because we are going to compute the average. First, we will compute the sum. And after computing the sum, we will divide it by the average divisor. Okay? So pwede rin pala yung isa kanina, no? Pwede natin tanggalin yung average divisor dito. Okay? Pwede natin itong tanggalin. Do you follow? And then in here we will say, we will insert S3. S003 will store the 3 here. Do you follow? So there's no more question about having to encode two values. Isa na lang, right? Because anyway, we are storing it here. Okay? So that's the same thing here. In the first we store the number 3 as the next addend, the decrement as 1, the first partial sum is 1. Okay? And then we do a times from 2, the partial sum is 1, and the next addend is 3, we do a times, so this is 3. The first partial sum is 3, the average divisor is right away also 3. Do you get my point? No? So this is a better version. Wala siyang, we have removed the duplication of the input, which is the number 3. Okay. First, we compute the next addend, right? What is the next addend? How do we do that? The current addend, which is L00, which is 3. Okay, ito 3, no? 3 yan, and then this is 3. We minus the decrement, which is 1. Okay. So 3 minus 1 is 2. Okay. And we store it to 000, which tells us that the next addend is 2. Okay? Okay. So let's proceed. The next is to compute the partial sum plus the next addend. So itong 3 plus 2. So we do a plus with L002, which is 3, and L00, which is 2. Okay, so the sum of that is 5. And we store it to the partial sum, which is 5 here, so that the partial sum is 5. Okay? Do you follow? Now, the next thing to do is to check if the next addend is a 1. Do you follow? Okay, is a 1. We have, incidentally, we have a 1 in the decrement. So we do that by setting a minus, no? So L001, this is a 1. Okay, do you follow? Okay. And then the next addend, which is 00, what is the next addend? It's 2. Okay, so 1 minus 2 is negative 2. Do you follow? This will set. Okay, this will set the run-up lever. Why? Negative 2, look at that. The sign of the egress axis is negative, and the sign of the ingress axis is positive. Do you follow? Which will result to a set. Okay, so to find out whether it will result to a set, we will check if the ingress axis, the sign, negative, ito, positive, so it will set. So we'll say CB11. It will jump, count backwards 11 because the run-up lever is currently a set. Okay? To determine that, you only have to check the sign of the egress and the sign of the ingress. So, which means we will count 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, we will go here. No? We will repeat. Do you follow? So, this is actually, I've labeled this pass number 1 because we will copy this. so that we will have a pass number 2. It's the same set of codes. The same set of codes, but we are passing through it the second time around. Okay? To make things clear, okay, so this will be skipped. Okay? These lines will be skipped because we will go to pass number 2. During pass number 2, okay, our next addend, what is our next addend? Is 2. Okay, our decrement is sum. Our partial sum is, what's our partial sum? 5. Is 5. Do you follow? Everyone, so we just have to check the ingress axis and compare it to the sign of the ingress axis 1. It will be set if. Okay, let's look at the example. Ito. 1 minus 4 will set the lever. 1 minus 3 will set the lever. 1 minus 2 will set the lever, but 1 minus 1 will not set the lever. Okay, do you follow? Do you follow? So, in this example, in this example, we have 1 minus 2, it will set. Right? It will set. Because it will not only set if it's 1 minus 1. Okay? Do you follow? Okay, so we are now in pass number 2. 0, 0 is 2. The next, this is 2. 0, 0, 1 is a 1. So the next addend is a 2 minus 1, it's 1. Do you follow? And we'll do a plus. Okay. We'll plus to compute the next addend is 1. Okay. There. We'll do a plus to compute the next partial sum. 0, 0, 2 is currently 5. Okay. Then 5. And then 0, 0 is 1, which is the next addend. So 5 plus 1 is 6. You follow? And we'll store it as our partial sum. So this becomes 6. Any questions so far? Any questions so far? So now we will set the run-up lever. L001. What is L001? It's 1. 0, 0 is, take a look. Okay. 1. Okay. 1 minus 1 is 0. This will not set the run-up lever. Do you follow? So which means we will not go back. Questions? Which means we will not go back 11 steps. Right? We will not go back 11 steps. Instead, we will move forward. We'll move forward. So we'll do a divide. L002, which is 6, and L003, which is 3. Do you follow? Okay. Mali ito na, this will be an S002. S002, I'm sorry, no? Dapat S002 because that will store the final answer. What do we have? This is an S002. Okay. So anyway, we are going to divide 6 by 3, which becomes 2. And we will store the final answer to 002. 6 divided by 3 is 2. So the average of the first 3 numbers is 2. We will do a PBH. Okay? Reject a call, okay? Okay? Do you follow? Any questions so far? So the average among the 3 numbers is 2. Now this is a version with a loop. So we can use this to compute any value. So which means if you will change this to N004, this will compute the average of the first 4 numbers. If we will use N005, this computes the average of the first 5 numbers. Okay? Do you follow? Okay. Any questions so far? Okay. Now the final item is compute centigrade to Fahrenheit. No? So it's like the Celsius, Fahrenheit to Celsius, but this time our input is in 000, which is 200. 200 is the value in Celsius, which we will convert into Fahrenheit. The formula is Celsius times 9 divided by 5 plus 32. Okay? You can Google that up. That's the value. So we have So this is like the sum of 1 to 3. Direct, you just do it directly without a loop. Okay. So and we have N00 200 as our ano. I don't have to erase this because it's simpler. 9 is our multiplier. Okay. 5 is our divisor and 32 is our addend. So first we do a times L00 with L001. So that is 200 times 9, which gives us 1,800. And S000 will give us 1,800 in ST00. Okay. Then divide it by 5. So we have divide L000, 1,800, L002, which is 500. So 1,800 divided by 500 is 360. We store it at the partial answer as 360. And finally, we will add 360 with 32. So we will have 392. And we will have a PBH. Okay. Any questions so far? Any questions? Any questions? So anyway, thank you. Now, I hope you. I will post this in Dagler. Okay. I will upload this in Dagler. No? Okay, we have recorded. Now I'd like to show you another program which uses a CF because students were clamoring for me to make an example to do of a CF. Okay, so I have it here. This is a grade computation program. Now what is grade computation? If every time you have an exam, no, you will compute the equivalent grade, right? The equivalent grade of an exam. Okay. So usually you will have a base of computation. The formula for computing the grade is like this. Score over items, or SI. Do you see that? No? Score over items times quantity 100 minus base plus base. Are you familiar with this? No, this is the formula. Okay. Okay. Let me erase everything first. Okay. First, let's have a passing example. No? So ST00 will store our base. So we have N00. We are usually base 40. No? N00 will store our score 001, and 002 is our items. Can you see my worksheet? Okay, I hope you can all see my worksheet, no?
Yes po, sir, makita po.
And the grade we will store here. Okay, 100 will always have to be done. You can also use an S later, no? But for the moment, we'll just store it here. And we will have passing as 1, which we'll store in column 5. Ito. And failing as 0. What we will do is we will compute the grade and find out if it's passing or failing. Do you follow? The result for passing and failing is here. No? And the cutoff, which is 75. 75 up will be passing. 74 below will be failing. Do you follow, everyone? Okay. So there's an if then else. No, like in a simple program, another version. You can do this in C++. No, you will have an if else execution. Do you follow? Okay. First, we divide the score by the items. Okay, 001 is 80. The number of items is 100. Okay, so this will be 80 divided by 100. So that we have 4.8. And we will store the partial grade here. So this is 0.8. Okay, any questions? Very clear, no? That score over items. The thing is, we will have 100 minus base. So that's why we have 100 here, because 100, this is the 100, no? This is different from the items, no? They're not the same. You cannot do a load and store here. So 100, this is used to compute the 100 minus base. So we'll have the base L004, which is 100, okay? And the base is 40. So 100 minus is 60. And we will store it in the temporary variable, which is 60. Okay, so that we'll get hold of it. No? Kasi if we don't get hold of it, we cannot multiply it anymore. Okay? What will we do with the 60? We are going to multiply 60 with 0.8. Do you follow? Okay, do you follow? We're going to multiply 60 with 0.8. So L003, we multiply L003 is 0.8. Okay, and 60 is in 7, no? Which is our 10.
Sir, may question ako, sir.
Yes.
Gina-assume to, sir, na 40 base?
No, you put the base here in 00 dito. Pag 40 base, you put 40 here. If it's 60 base,
Yung grade talaga nito na computation is 40 base.
this example is 40. Particular
Okay.
example. But you can use this program to do computation for 50, for 30, for 40, for 70, whatever you like. Do you follow?
Yes, sir.
Di ba? Pwede mo itong gamitin sa 50 because you'll just change this to N0050. This is now 50 base. Do you follow? For example, I'll make this N0050. This becomes 50, right? Ito magiging 50. Right away, this is 50 base computation. Nawala yung aking keyboard. I'm sorry. Okay. So this now becomes 50 base. Right away, it will follow. Everything will follow. Okay. Anyway, in this example, we are using 40 base. Bakit ganito yung aking ano? I have a problem with my Excel. I-close ko muna ito. Yung isa. Okay. Okay. So we now multiply 0.8 with 60. We'll just make a formula. That's 48. And our partial answer for the grade, we'll put it here, 48. Do you follow? This is our partial grade. Are we done? No, because we still have a plus B. Right? We have multiplied with 100 minus B. We will now have a plus B. So plus, the base is in 00, which is 40. Okay. 003, which is 48. Okay. So the plus is 88. S003, which is 88. So the numeric grade is 88. Do you follow? Now we will determine if this is passing or failing. Obviously, this is passing, right? But we will let the program determine whether this is passing or failing. Now remember, in 006, we have 0 as our failing, and 005, we have 1 as our passing. Okay? Do you follow? First, we will assume that this is failing. And if we are wrong, we will correct it to passing. That's the logic. Do you follow? First, we assume it's failing. 006 is 0. 005, sorry, that's 0. 005 is 1. Okay? So we times 0 times 1 is a 1. And we will store it at 9. So our result is initially failing. Do you follow? Do you follow? And then we will do a minus to set up the run-up lever. 008. What is 008? 75. This is our cutoff. 75. 003, which is 88. Okay? 75 minus 88 equals this. Okay? CF4. Okay? Let's look at the ano. Okay? Let's look at this. Okay? CF4. This will set up the run-up lever, right? Because this is not 1 minus 1. Okay? The result is not a 0. The sign here is negative. The sign here is positive. So CF4, what will we do? We will move 4 steps forward. 1, 2, 3, 4. Do you follow? Do you follow? Okay, anyway,
Yes, sir.
We will have an example which is failing, no? Okay. I'm sorry. Times. So hindi tayo mag-PBH. We will do a times. What will we multiply? L005, which is 1. Another L005, which is 1. 1 times 1 is 1. We will store it here. And we'll do a PBH. So what is the result? It's 1. It's passing. Sir, ang egress access AX mo po sa S009 is egress access sa 009. What line is that? Paraiso?
Sa SO9, sir, dapat 0. Sa egress AX.
I don't hear you. I'm sorry, I don't hear you now. Can you say it again? Sa line 30. S009. S009 is 0. Because 0 times, 0 play time, sorry. That's a 0, okay? That's correct, no? Okay? S009 is a 0 because 0 times 1 is a 0. Okay? That's correct, no? So sa 29, this is a 0. Okay, that's correct. Thank you, no? Miss Paraiso, thank you. Okay? That's correct, no? Okay? So we still have the same answer. The grade is 88 and the grade is passing because this is a 1. Any questions so far? So let's try a failing grade. What is a failing grade? 60. 60 is failing na ba? 60 over 100. 50 na lang. Okay? No? Equals 50 over 100 times 60 plus 40. 70, yes. Okay. If you get a 50, you will fail, right? So we will erase this. No? Okay. If you will get a 50 over 100, you will fail. We'll find out, no? So first, we are going to divide the score over the items, okay? Divide the score is 50. The items is 100. Okay. So equals this divided by this. So 0.5. S003, this is 0.5. Okay. Divide. And then we will compute the 60. Okay. We will compute the 60 by minus the 100 minus base, which is 40. Okay. So 100 minus 40, this is 60. We will store it at the temporary column, which is 60. Do you follow? Okay. Okay. Now we will multiply the 60 with the 0.5, right? Because we have score over items times 100 minus base. So the score over items is 0.5. We have it here, no? At 003. And the 100 minus base is 60. We have it there, no? Okay. So we will multiply. Or sorry. Equals this times that. We have 30. Okay. Okay. We have 30. And we'll store it here at the partial column. Okay. Partial grade. 30. And then we will plus it with the base. So L00 plus the base is 40. And L003 is 30. 40 plus 30, that's 70. Do you follow? S003 will store the grade at 70. Do you follow? Do you follow? 70. Okay? Okay? 70 na siya ngayon. Okay? And then, we will assume that the grade is failing. Okay? Times 006. 005 is 1. 006 is 0. Baka baliktad yung ating kanina, no? Anyway, it's the same thing. 1 times 0 is a 0. They follow. And S009 will have a 0. We assume that it's a failing. Okay, you follow? And then we'll check if it's failing by deducting 75. We will minus 75. Okay, and the current grade is 70. Okay, so 70 minus 5 is 75 minus 70 is 5. Do you follow? Now, will we skip? If it will set, will it set? No, it will not set. Why? Because the egress is positive. The ingress is also positive. They have the same sign. Do you follow? Do you follow? And so we will
Yes,
have
sir.
a PBH. So what's the result? The grade is failing. It will not compute for anymore for a times here because we have a halt here. It's like an exit. Okay? Any questions so far? So this is an example which uses a CF. As I've mentioned before, the CF is used in an if-else statement. Okay, you can see a lot of this in the source code of Ada Lovelace, no? Count Ada Lovelace. Do you follow? Augusta Ada Lovelace. Now we have done this, no? We have, for sure you can do a lot of other computations, no? Other programs like uh, computing the variance, no? Computing statistics and so on and so forth. You can do conversion from meters to feet to inches and so on and so forth, no? You can do a lot of things. But what did uh, Ada Lovelace do in order to be able to convert? Kasi the problem with Charles Babbage's problem is nobody recognizes the worthiness or the worth of the analytical engine. When he presented it to the scientific community during the 1800s, no, during his time, nobody paid attention to the invention because for them this is too advanced. This has no application. This serves like some people even branded Charles Babbage to be out of his mind for having computed, no, for having invented such a useless machine. But when Ada Lovelace saw the machine and studied the design, she found out that this can have several uses. So in order to prove that, she wrote so many algorithms to show to the scientific community that this invention has many other uses. Do you follow? Yun yung sinabi niya. This has many other uses. So what did she do? She made several programs. One of them is what? The Bernoulli computation. Okay. Ito, no? It's here, no? I'd like you to watch this. What is the Bernoulli number? The Bernoulli series. The Bernoulli series has applications in polynomials, no? Let's look at the Bernoulli series, no? Nag-invento ng numbers na ito is Bernoulli himself, no? This is how to compute the Bernoulli series, no? If you have the first zero, the Bernoulli number of 0 is 1. The Bernoulli number of 1 is 1/2. The Bernoulli number of 2 is 1/6. The Bernoulli number of 3 is 0. Every time n is 0, the Bernoulli number is 0. Or rather, every time n is odd, the Bernoulli number is 0, except in 1. No? Kasi sa 1, 1/2. On the third, it's 0. On the fifth, it's 0. On the seventh, it's 0. Okay? On the second, it's 1/6. On the fourth, it's 1/30. On the sixth, it's 1/42. And then negative 1/30. The Bernoulli series is otherwise called the Summae Potestatum. Potestate, no? In Latin, because during those days, no, mathematicians wrote in Latin. Okay? Which means the sum of powers. This is the exact formula, this is the actual formula used to compute the Bernoulli numbers. Do you follow? Do you follow? And Ada Lovelace showed that this series can be computed by the analytical engine. This is the actual code. Do you follow? This is the actual code of the Bernoulli series. So here are the card operations, no? The number of operations, no? 25, no? It can compute up to 25. First, to compute the first in the series, you will have times. Times. What are the variables needed? V2 and, I hope you can see, this is a very old document, no? V2 and V3. So V2 is store 2, variable 3. Kasi unlike nowadays, no, we call them the store. Ada Lovelace calls them variables, no, V. Instead of S, he uses V. She uses C. V. No? She used V. So V2 means variable 2 of the store. V3 means variable 3 of the store. The result of the times is stored later, no? Gagamit siya ng S to store the result to 4, 5, and 6. So IV2 is equal to IV2, IV3 is equal to IV3, V4 is equal to V4. Do you follow? Okay. Remember V2 times V3. Okay. And then it's stored to 4, 5, and 4, 5, and 6. Do you follow? The actual results are stored to 4, 5, and 6. Now, in the second, you will have a minus. Minus of what is in V4 and in V1. Do you follow? So, she also did a trace. Look at that. No? And instead of our case, we use ST, right? In her case, she used V. So, this is IV1, which means this is V1, variable 1. Or this is store 001. This is store 002. This is store 003, but it has a value of 4. This is store 004, 005, and this has the value of 00, and so on and so forth. The working variables are like the temporary variables that's used, V1, V12, V11, V12, and V13. These are the working variables so that she can store temporary values. Did you follow? Did you get my point? Now, can you trace the Bernoulli series using this program? Given n as a value? Of course, we will not do that. No? Okay? We will not do that anymore. But she was able to prove that the analytical engine, which was an invention of Babbage, has much more enormous uses other than just a play toy. Do you follow? She became very popular on this. In fact, she did a lot of suggestions. She wrote charged by Babbage several times to make suggestions. And they communicated with each other, no? In fact, okay, ito yung tale nila, no? Okay, ito yung tale nila. Ada Lovelace discovered the work of Charles Babbage, no? When she went somewhere, no? In where's that? She discovered, okay, and then she made okay. She read the book, no? Itong Logarithms of Natural Numbers, okay, which was written by and then okay, many works, and then Ada Lovelace wrote the programs on the algorithms running, to run on the and in fact she became very much engrossed with the analytical engine that people during those times believed that she may be able to snatch away the design of the analytical engine from Charles Babbage. But she did not do that. Instead, she just wrote algorithms. She made several suggestions, and then Charles Babbage also pointed out suggestions on his code, on her code. In fact, ito yung sabi ni Charles Babbage replied to, she wrote a letter to Charles Babbage, and Charles Babbage made a reply several times, 4 times, This is the letter making the suggestions. A variable card may under any number of variables to receive the whatever it is, it's very difficult to understand because of the penmanship during those days, They follow? This is a letter by Charles Babbage telling Ada Lovelace what to do in order to be able to solve a problem on the analytical engine. Okay, do you follow? Now, after that, the sad thing is, it was Ada Lovelace was the hope of the analytical engine because she has the capacity to assemble it into a real machine because she's rich. Unlike Charles Babbage, who was waiting for funding from the government. Okay, so he was ill-financed. However, the sad news happened when Ada Lovelace died at an early age, at the age of 36. He got sick, no? She got sick, which caused her to die at an early age. And after that, nobody paid interest to the analytical engine anymore, such that the technology died a normal death, no? So during those times, no, nothing happened when uh, Ada Lovelace passed away. Nag-pass away, nawala na yung technology, nobody developed it again until 1950. Okay? When the work of Charles Babbage was rediscovered, no, by a very known mathematician named Alan Turing. Okay? So si Alan Turing ang naka-rediscover, especially during World War II, during 1950. And he was able to demonstrate that Charles Babbage's invention was indeed a complete computer. Do you follow? Do you follow? It's a complete machine. Okay? Any questions? So that's their story. Ayan, yun yung story niya kung paano nangyari yung the invention of the very first computer. Okay? Okay? Now, let's look at what happened after Lovelace, no? And Charles Babbage. This is from Wikipedia. Let's look at Wikipedia na lang. Ito, no. Okay, let's look at Wikipedia na. Okay. So ito yung analytical engine na partial invention. It's not a full invention by Charles Babbage. So ito yun, no? Can you see that? You can browse this yourself, no? That built, no, it was designed during the 1830s, particularly 1832. It started there. Now, these are classifications, no? The number system used in analytical engine is decimal. It was mechanical. The programming is done by punch cards, no? Is it Turing complete? What do you mean by this? Because Alan Turing rediscovered it. When you say a machine is Turing complete or Turing finite, we mean that all the states possible on the machine are established, which means that all the states are known. It's like a Turing complete machine is like a perfect program. It's a program without bugs. Will always work for any input that is given to it. You give it any input, it will work. It will process and produce a result. Do you follow? When it's not Turing complete, there are results which cannot be computed. Do you get my point? No. So Ludgate tried to reinvent, no, during the 1909, which also was not successful because there's not enough technology. Irish, he tried to reinvent, no, the analytical engine. Now instead of using wheels, no, he uses state of rods. We will look at this, no. Rods kasi the state of rods is either magnetized or unmagnetized, no. So there's a way to do that using magnetism. There's nothing about, Ludgate yet, but we will look at that. We'll look at Zeus. No? Zeus Z1, 1939. This was the first attempt to invent, a mechanical computer based on Charles Babbage design. It was this time it's not decimal, but it's a binary floating point number. No? But binary floating point machine, which means that the numbers are not in binary, rather decimal. They're in binary. It's mechanical, and the programming is done on tapes, no? 35 millimeter films. Okay? Tapes na siya. It's not Turing complete. And the memory used is state of rods. Okay? And then, during the advent of the Second World War, no? The Polish invented the bomb with an E. Who after the inventor, no? It was called bomba, no? Because it is used to decrypt, no, encryptions from Enigma machines. Enigma machines are machines used by the Nazis, no, to encrypt their messages before sending them to the front line in the war to avoid being understood or being discovered by spies when they intercept the message, when their messages are intercepted. No? So ito yung mga rotor Enigma. Oh. Magaling rin yung mga Nazis, but there are not much information about the Enigma machines. No? Enigma machines are computers by themselves. No? But the design, there's not much information regarding the design. No? But the bomb, which is a descendant of the analytical engine, was invented, no, during 1949 and went over to the British during the 1940s and eventually captured by the US in 1943, which became the basis of their discovery of or invention of another computer later. No? Zeus Z2, binary floating point, also invented by Conrad Zuse. No? This time, this is electromechanical, including its memory. They follow? Mechanical kasi yung ano, Z1. Okay, and then Z3 is electromechanical. Okay. By 1942, another descendant is the ABC computer, Atanasoff Berry computer, by John Vincent Atanasoff, Iowa State University, no? From Iowa State University. John Vincent Atanasoff and Clifford Berry. Okay, they released it during 1942, during the war. No? Now, it was not considered a full computer, but the significance of the ABC computer was that it was the first machine that used the regenerative capacitor memory. So electronic, this is fully electronic, which means that it uses the same technology, capacitors, no, used in our memories, computer memories at the present. No? However, it was not used because it's not Turing complete. It's only used for programming linear system coefficients using punch cards. Any questions so far? By the way, Z1, Z1 was Z2 rather, Z1, Z1 ba? No, Z2 is considered to be the first generation computer. Electronic naman. No? Pag mechanical, hindi pa first generation. The first generation computers are the electronic computers. No? Z2. Okay. Any questions so far? And then, by 1943, the UK invented Colossus Mark I. Incidentally, it's called Mark I. Basically, to do decryption of Enigma messages. No? So, war machine ito. Colossus Mark I, this is a war machine. No? Vacuum tube diodes, no? For memories. That's the main ano. It's also binary and electronic. Now, by 1944, Harvard embarked into a study with IBM to invent or to assemble a machine patterned after the analytical engine by Charles Babbage. No? It's by large mechanical. No? 1944, it's decimal like the analytical engine. It's also programmed using punch cards, and it uses mechanical relays. It's like a mechanical horn relay. It's like a transistor already, only mechanical. It's not Turing complete. Now, Harvard Mark I became important because it's the first computer invented by IBM. Do you follow? Invented by IBM at Harvard. Now, there was an important jargon that was coined during this time. It's called the bug, because one time, no, the Mark I malfunctioned because a moth was caught in between one of its gear. So later, when they were trying to solve the problem, they found out that the cause of the malfunction was a bug in between the gears. Okay, so nowadays, when you say a bug, we mean a defect in a computer program. But in those days, a bug was a moth caught between the gears of the IBM Mark I, which caused it to malfunction. So nowadays, when we say a bug, we don't mean a moth. We mean an error in a computer program. Okay. So Zeus Z4, 1945. No? Z4 is the first commercial digital computer. They follow. It was the first digital computer which was sold commercially. Okay. So anong unang nabenta? Because of course the ABC and the Mark I did not sell. The first commercially sold computer was Zeus Z4 by Konrad Zuse, also from Germany from 1945 to 1948. It's binary floating point. Do you follow? Let's look at the Z4. No, it's binary floating point. Okay. So it can now do floating point operations. It's electromechanical and it's first Turing complete. It's the first binary computer that is considered to be Turing complete, which now is a fully functional machine. Mechanical relays are used for memory. By 1946, no, the US in Pennsylvania State University, Penn State, no, invented the ENIAC. It's like the electronic equivalent of Charles Babbage analytical engine. Do you follow? Oh, ito. ENIAC. It's electronic, but it's decimal. Do you follow? No, look at the ENIAC. Oh. Do you follow? It's electronic, but it's decimal. Okay? So, by 19, we will study the ENIAC, no? We will look at the unique inventions found in the ENIAC. By 1948, the UK released Manchester Baby. It's also binary, electronic, and the first third program digital computer. And it's the first computer that comes with a keyboard. Do you follow? Do you follow? Which computer comes with a keyboard? It's Manchester Baby during 1948. Bear this in mind, no? That's a trivia in computing. The first computer with a keyboard came in 1948. Is the first third program digital computer. Ibig sabihin, the programs are not running on the punch card. Do you follow? The programs are not running on the punch card, but it's running in memory. Cathode ray tube na memory. So it's now fully electronic. Do you follow? So you see the history behind na the analytical engine. Now next meeting we will look at ENIAC. It's good to look at Z4, pero is there a good documentation about Z4? Wala masyado, no? Wala masyadong programs. Do we have programs on the Z4? Wala masyadong programs, no? But the first commercially produced binary computer is called the Z4. It was sold for 3 years, from 1945 to 1948. Okay, we will have an exam on this, okay? Tingnan natin ito. Okay? Any questions so far? So we're done with this, no? This part of history. We're done to this part of history, no? Ano pala, ENIAC is by J. Presper Eckert and John Mockley, no? J. Presper Eckert and John Mockley. University of Pennsylvania. These are the early inventors. John Mockley, and then followed by a very important invention called John von Neumann. Okay? (1945) for use by the Army. Hindi nakasulat dito eh. No? Ito. ENIAC was designed by John Mockley and J. Presper Eckert. Penn State University School of Engineering. Now, Penn State is very popular until nowadays. No? It's where Donald Trump finished college. Okay? So, meron silang Wharton School of Economics, and then they have Pennsylvania Engineering. No? What's that called? School of Engineering and Applied Sciences at Penn State. What's the School of Engineering? What's the name? May pangalan eh. It's not, Wharton is the School of Economics. No? Anyway, we'll look at that when we'll look at India. Any questions so far? So this is recorded, no? I will upload this to Dagler. Any questions? All the solutions I'll upload to Dagler. Next meeting, we'll have a new topic. Okay? So, we'll end at this point, no? In a way, there's malik konti na lang oras. Okay? So, see you next meeting, everyone. Did I miss any attendance? Okay. Okay. Thank you very much. No? Goodbye, everyone.
Goodbye, sir.
Bye,
Thank you
sir.
po.
Thank you,
Sir,
sir.
thank you
Yes,
po,
sir.
sir. Thank you,
Bye, sir.
sir.
Thank you.
Goodbye, sir.
Thank you, sir.
Thank you po, sir. Sige po.
Thank you, sir.
Thank you very much.